This is the second video of data analysis, video analysis using Logger Pro. Now we desire to not just look at position but determine quantities such as speed and acceleration. And there are different ways of going about doing this. If you look at the data table over here, this is this video we had last time, so I still have that same analysis. You'll see that Logger Pro, if you move over, Logger Pro can actually calculate the velocity for you. It's calculating velocity as a difference of position divided by a difference in time. So if I go back here, by taking the difference of positions divided by the difference of times, it can calculate the velocity. It does a slightly more complicated calculation to try to smooth things out a little. We can add graphs, insert a graph, and when I do that it will show the graph of its calculated velocities. Over here it has automatically picked the y velocity. If I click on where it says y velocity and click on x velocity instead, it'll calculate the x velocity. If I right click, I have a little more leeway. I can go to graph options, axis options, and I can tell it to graph both the x velocity and the y velocity at the same time if I want. And there I see both of them. Another option, if I don't need to see the entire graph, so I will delete this, is there is a tool up here, has a little m equals, and if you hover over it, it says tangent. So when I use that tool, I've already selected it, so now it's gone. Now I'll come up here and select it. So as I move the cursor around, it will actually find the slope of the line tangent at these points, which is another way of finding a velocity component. If you've had calculus, it's like finding a derivative. If you haven't, ignore what I just said. So up here, it is showing you the slope of the tangent line at each of these points. And I can follow these through as I want, both x and y. Now if I look at these graph options again, I can deselect x and y, and once again select x velocity and y velocity. And this will show the graphs I had before. If I want, I could do the same thing with the tangent on these graphs. Now the slope of the tangent is the acceleration. So again, up here, it is showing me the slope of the tangent's line, which is now the change of velocity per time, which is the acceleration. Now, in other situations, there's another way of getting to the slope. And I will therefore this is a graph I was looking at, so I will get rid of it. And I will start from scratch. If I go to experiment, or go to data, and I am just going to clear out all of the data so I can start from scratch. Now I'm going to use a different video. I will insert a movie that is built in. This will be physics with Vernier. Advanced physics, mechanics, I suppose. Basketball shot. And as a reminder, I can play the video. I can step through it frame by frame. So that's a good place if I want to analyze the ball as it goes through the air. It has left his hand at this point. Click on the button that gives me the various analysis tools. And start adding points. So I will use the center of the ball and click on the center of the ball. And I will do this for a while. I won't do the entire flight of the ball. Okay, now I want to set the scale. That again is this button here. And I can drag across here. And suppose that distance is 2 meters. I can also set an origin. That was this button here. Pick the origin, say, at his feet. So now the blue dots are the positions of the ball at different times. And the table contains the values of the x and y coordinates of those positions, and that also is what the graph shows. I can add a graph that has the velocity again. Now if I use the slope tool, the tangent tool, it's very unsteady. It's bouncing around, bouncing from place to place. One way of, if I believe that this is overall a straight line, one thing you can do is to turn off that tool, select the range of data you're interested in, and then go over here where there's an R equals, and that gives you a linear fit. It fits it to a straight line. So if this is a velocity versus time graph, the slope of that straight line would be the acceleration. Okay, so I can delete that graph now, or just move it to the back. And here is the position graph I had previously. Again, you can fit that to various functions if you want to. So I can look at, say, the x fit to a position. The x is selected, and I can pick something I want to fit it to. Say I can try a straight line. If I don't believe the straight line is a good fit, I can try a parabolic type line.